Great. Thank you, UCL200, for having me. Thank you for being here. It's a proud moment to present part of this work with you. My name is Argyris Oraiopoulos. I'm a senior research fellow at the UCL Energy Institute. I'm part of the Building Stock Lab, and my work is focusing mainly on urban building energy modeling and thermal comfort, both in UK, but also in places like Peru, India, and most recently in Brazil. So future cities. I think we need to think about who is designing these cities and who for, who is benefiting and who is being left out. And with that, I present you one of the most common themes when we talk about the future of cities. They are ultra green. Very often they've got this amazing blue elements. They have very clean, crisp lines. They have streets and roads where there's very few cars, very few people around. They have these landmark buildings that sort of signify some importance of the landscape. They have PVs on top of every single roof. To the extent we go that far, that we start materializing the absolute impossible in the most hostile terrains. But the reality is very often quite far away from that. And there are a lot of cities that have absolutely no green, they have no blue elements, there's no PV roofs, and the people there make their own realities. And the matter of fact is that 27 out of the 33 megacities across the world are actually hosted in the global south. And they accommodate over 75% of the global urbanized population. And by 2050, the UN has estimated that the urban population will grow from 4 billion to 7. And this 3 billion increase, 90% of that will take place in the global south, and especially in low to middle income countries, where the main form of urbanization is via informal settlements. And these informal settlements, they're not going to grow in the future, they're growing as we speak at the moment. And they're growing fast, not necessarily in numbers, so we don't have many more of these settlements, but they're growing in population. They're growing to an extent of even 200% year on year. And they evolve by the people, for the people, with very little planning, with a lot of self-construction, and with very slow progression and evolution. People go there, they build one floor, one house for them and their family. 15 years later, they might build a floor on top of that. Another 20 years later, they might just build a floor on top of that with no formal planning, and we end up having a situation where the urban environment has a lot of different issues. I've got here the 3D reality models of two different settlements that we've explored. The one on the left-hand side is still consolidating. It started in the 90s, and it's still growing, while the one on the right-hand side has been consolidated. It started in the 50s. They're quite close to each other. They're both in Lima. And what you'll witness, what you'll see here, is that the one on the left-hand side, the density is quite low. And the one on the right-hand side, the density is such that there's no single space for anything more. There's buildings absolutely everywhere. But they both have issues. They both have very big issues. The one on the left-hand side that it's still consolidating, we see very poorly constructed housing, and that can lead to exposure to significant and very strong thermal stress, both feeling very, very cold during cold weather in the winter and very, very hot during warm weather in their summer. And on the right-hand side, we might not have these extremes in terms of thermal stress because obviously the materials are different, there's more thermal mass in there, but the fact that the density is such high and the wind flow is disrupted, we start having issues with very high relative humidity and mold growth in the living spaces. Therefore, overall, people are locked in these vulnerable futures for many, many years. Obviously, it starts from them being in a very low income, all right? But this then continues to their housing being very poorly constructed, and that brings in exposure to high thermal stress and adverse health impacts. And obviously, their inability to access energy because of the lack of the state and the lack of formal planning, it means they cannot mitigate these exposures and these risks. And our projects have devised a participatory workflow where we work in 3 different scales. We work at the community, we work at the building scale, but also at the large urban scale. And we bring in the occupants very early on in the process, and we work with them throughout the project. We work with their buildings to understand the building physics. We monitor and we model individual buildings, and we take those learnings into the large scale where we can assess risk on a community scale. In more detail, with the community, we try to co-create parts of the project. We try to co-design alternative futures for them, and then co-produce and materialize this on the ground with them. We've got our lovely colleague Patricia in the middle of the photograph. We've got Mari, we've got Andre in the background. We've got communities and workshops that grow each time. We get more and more people part of the group. Then on the building scale, we monitor indoor environmental quality parameters, which we use to calibrate our models. And then we use those calibrated models to test our proposed alternatives for their futures and for their buildings. And then we materialize this in prototypes. In this case, I've given you a case study where we've changed the roof. We've added only 5 centimeters of expanded polystyrene in the roof, and the result was a almost 10 degrees difference reduction in the daily maximum temperature, and therefore really having a big impact in terms of their risk, their health risks. And then we take these learnings and then we apply them. We use UCL developed software, SimStock. We've got colleagues in the audience that have been instrumental in developing this software. And we use this software to test our alternatives into a very large scale. Here I've given you a map where we visualize what otherwise would be invisible, essentially. A change in the roofs of these settlements. We were changing the metal sheet roofs to adding a small bit of this EPS insulation, and then we can visualize the change. We can measure the cost because we know the absolute area of every single roof, and then we can also measure the savings in terms of the local national health system, how we would benefit from that. Our key message here from all this work is that by producing evidence from prototypes and community scale modeling, we can apply passive, adaptive measures that can lead to very clear improvements in the health of the occupants. We can transform this way the daily lived experiences at a very low cost and at a large scale. And we do this by co-creating with residents, and we've seen remarkable results that are more effective, they're more culturally grounded, and they can be very rapidly scalable. In this way, we support policy and local decision-making and moving towards prioritizing climate-resilient housing for the most vulnerable of the communities. Before I finish, I'd like to acknowledge the significant work of our amazing partners across the world, as well as the generosity of our funders, without which none of this would be possible. Thank you very much.